Okay, so here is our lab experiment 2, or which you are going to submit again now as lab presentation. So this is now number 2. So we call this as the parallel plate capacitor, and our objective for this activity is to determine the effects of the voltage, no, that your battery may have, no. So what if you are going to increase or decrease the voltage of the battery? What's the effect of the area of the plate, and no, the distance of separation? Now, we mentioned about 3 factors earlier, and however, no, in this activity, we will not use, or we will not perform all of those 3 factors, but instead of the dielectric, the effect of the dielectric, we will just have the effect of the voltage, no, on the overall capacitance. No? Again, now we will be using again, no, another FET simulator, and we'll call the FET simulator as the capacitor lab, no, the basic one. No? And again, now here's our data that we'll be gathering today. So in our data that we'll be gathering, no, first we will be setting the voltage of our battery, no, into 2 different settings. One which is, if we could set it at around 0.45 volts, and no, the next one, after increasing it, no, make it into 1.2 volts. You can actually, no, if this value is difficult for you to attain, because maybe the knob will not really give you, no, 0.45 volts, you may also, no, opt to have a different value here, no, for the voltage. But again, no, one must be lower and then the other one must be higher. No? Now for our first set of, of data to gather, no, we will have to keep, no, the same or constant the distance of separation. No? All that we are going to vary, no, for this table is the area of the plate. So the nature of the area of the plate should be increasing in value. No? So from trial 1, you have to make the area there larger and larger, but you have to set a distance that you will probably fix, no, all throughout trials 1 to 5. So this is kept the same, the distance of separation, while the area of the plate must be made, not to increase larger and larger. And then you are to gather, no, the charge, no, in the plate, and likewise the value of its capacitance. No? So our unit for the charge must be in picocoulomb, while the unit of our capacitance is in picofarad. Okay, so again, no, this is our first set. So at that particular voltage. Now next, we will have to increase the voltage in our next data. So from 0.45 earlier, we will make it 1.2 volts. But at this point, no, the data gathered here will have, no, the area of the plate maintained, no, or made constant. So at 1.2 volts, so from trial 1 to 5, you will identify a specific area of the plate, no, and you are to write it all throughout, no, the same. And then, however, no, the distance of separation, you are going to increase it, no. So from trial 1 to 5, you will have to decide as a group, no, an increasing value of letter D, no. Now, you are to record, no, the charge, and again, no, the value of the capacitance in this column. So again, no, there's no computation for this one, no, because, no, the values there are determined by your simulator. So you simply gather the data there, no, and again, no, try to fill up, no, this portion here as a completion of your activity. Okay, so that's with, no, our. So if we are now continue, no, and proceed to our simulator. So that was our template earlier. And when you go to the capacitor lab basic, no, which is our simulator, there are 2 settings here. Now, to make it, no, a little bit more interesting, so let me just choose, no, so, or your activity, let's choose the light bulb, no. So we are going to select this one, no? And we are trying to open it up, and we will be shown here a parallel plate capacitor. No? So our parallel plate capacitor will allow us to use, no, this one is a voltmeter, guys. No, so we will use the voltmeter. So in an actual device, this one determines the voltage or the potential difference. And then it has an electrode, no? So you can probably place it here at this location, guys. And then therefore, now that will tell you of the voltage that you set the battery in. No? So you'll notice that the knob or the voltage of the battery can be varied. But again, no, there's no way of knowing it no, without this voltmeter. No? So the voltmeter allows you to have a reading here. No? So again, now in your first table, you have to set the voltage in the capacitor, no, something lower, and then no, or sa the voltage of the battery something lower, and then you increase it, no. So you can either move it up, and since we have no way of reversing the direction, then you have an option to reverse the direction of the voltage, no, or the battery, and then therefore no, the top part will now become negative, no. Yan naman na niyang positive diri sa dalom, no. So again, no, other ways of reversing the battery, no. So again, so you can increase the battery from 0 and going up, no. Now, there are two values that you are to record. One is the capacitance and the charge in the plate, no. So you can check this one. So you will be able to know how much is the charge and the capacitance value in the plate, no. Now you can also now make the plates move closer to each other, and you see the distance of separation to be marked this way. So if you move it closer, then you now have a 2 millimeter distance. If you move it further apart, so this one is probably roughly 10 millimeters apart. So again, now this is how we vary the distance of separation, and this is how we vary the area of the plate. So the area of the plate increases as you move it backward. So this is around 400 millimeters square. So again, now we charge our plate, and if you want to see charge there, maybe now you see the charge now as you increase the voltage. Now, when we charge the plate, so we use something like 1.05 volts here, in this setting, and again, we have the distance of separation at 2 millimeters and an area of 400 millimeters, millimeter square. Now we can detach the capacitor here, and by clicking it, then maybe now we can transfer the voltmeter in this end, there is a may bombilya in our bulb, and then therefore since the plate now is kind of charged, so you have detached it from the battery and the plate has become charged now. If you are going to transfer it here, then you'll notice that the bulb now lights up, but you notice it is now lowering its voltage. And then again, you'll see a corresponding capacitance and the charge in the plate. Okay, so again, we have this for you to observe the effect or the nature of our capacitance. So hopefully that is clear to you.